Do you mind your voice being heard and then us focus on the image and you explain what it is? How about that?
This is our high volume, high capacity bubbler.
So you've converted a water filter. Now what's this thing here then?
This has been threaded. There's a, this is a check valve. So if you do have an explosion in here, it doesn't push the water down up into the tube and back into the chamber. I just took one that's adjustable and adjusted it so that it takes very little pressure to open it. There's an adjustment screw on it.
Where do you get such a thing?
Lowe's, Home Depot. It goes into there and it can't go through the water. At the bottom of that tube is that black cap on the bottom is a diffuser. It's drilled full of little 16-inch holes.
Okay.
So it diffuses the gas flow into small bubbles that comes up. So
right.
There's a frame that goes on this, on the bottom and to the top, and connected with threaded rods used for tightening to clamp the lid on. That frame has not been assembled yet for this particular unit.
And that just gives it strength.
So no, it actually holds the top on because there's a gasket in here.
Okay.
If you look down in here, say it's just made out of a silicone, a bead of silicone.
Now, when you're referring to a cell, you're referring to each one of these plates?
Slots between the plates.
The slots between the plates are what a cell is?
Yes. See, the only plates that are actually electrically connected to the conductors at the end are the end plates. Well, what happens is the conduction in each cell couples the electricity into the next cell.
But there are people who are running a wire from plate to plate, skipping every other plate, and you're not having to do that.
I'm not doing that because that's a parallel setup. I'm doing a series setup.
Now, what kind of spacing do you have between your plates?
1/8 of an inch.
And what are you using to space them? Oh, and you just set your plates down in there.
Yeah, there's an extra piece in here on each side and an extra piece in the bottom. So the plates are totally isolated.
No chance of them,
They're separated from one another. So if you apply liquid here, it takes a long time for it to migrate through. The slots are milled 3/1000ths of an inch larger than the plates.
Right.
Which allows a little bit of fluid to pass through around.
Okay.
So it can still equalize.
Right.
You know, electricity follows the path of least resistance. Because the electricity would have to flow around the end of that plate, it's less resistance for it to go through the plate. You'll see what happens when I power this up. See how low the level is in here, right? Okay,
normally
all the way across. You'll hear the bubblers start going. Hear it?
Yeah.
Watch the level climb. See the level coming up? See, it's leaking right here.
Now the level's coming up because of bubble production? Is that the space occupied by the bubbles causes the water level to go up? And where's the gas going to?
We vent the gas outside so it gets rid of the explosion hazard in the building.
Now, is this all you're using as your generator?
Power source, yes.
So basically all you have there is a
bridge rectifier with a filter cap and just going into an outlet. This is not a resonance unit. This is just straight DC.
Right. And yet, even with straight DC, you're efficiently producing gas.
Yes.
In excess of Faraday's law.
Yes.
So there's the hydrogen gas output. This device putting out or drawing 143 volts and 4.6 amps.
Faraday's 1.6 amps per liter. I think we got six liters here. That's the amperage you should be requiring to generate that gas we're generating right now.
9.6. Okay. As the temperature rises, what happens?
Higher output. Voltage goes down, current goes up, the unit becomes even more efficient because the resistance drops.
How many liters per minute to run a typical 4-cylinder engine?
Right, well that depends upon the gas. See, standard diatomic hydrogen is parahydrogen. Hydrogen that's produced by an electrolysis cell is 75%, typically 75%. Orthohydrogen.
Right. And which is more powerful?
Orthohydrogen.
Okay.
It decays into parahydrogen.
So if you burn it quickly before it has a chance to recombine, is that the idea?
Yeah, it has more output, potential output power.
And
then monoatomic hydrogen, because see, orthohydrogen is still diatomic. Monoatomic hydrogen is individual atoms of hydrogen.
Okay.
When you burn monoatomic hydrogen and monoatomic oxygen, it yields 4 times the amount of energy of diatomic because it takes energy to break the bonds of the molecules, to break it apart, to recombine it back into H2O.
So you're saying then is you need a fourth as much hydrogen gas if you're using monoatomic
versus diatomic.
So if somebody claims that you need X number of liters per minute to run an engine, and they're talking about diatomic,
H2.
then you need 1/4 of that.
I mean, according to Faraday, we shouldn't be able to do this.
Yeah.
Right.
But with series cells, we can.
You're saying that this would run perhaps a single-cylinder engine or something?
Yeah.
Suppose I were to, right now, take this out to my car and hook up an inverter and drive home on it. What would it do?
Give you some pretty good gas mileage. This was an experimental prototype that we used for being able to monitor our efficiency based on the number of cells versus voltage applied. This will take up to 16 plates.
Okay.
And if you notice, the sides are spring-loaded, so you can just slide more plates in.
Oh yeah, what an excellent idea. Yeah, but this is a good example of how it is done.
Pulse width modulator, and 3 stands for the number of pulse width modulator stations it has. It has 3 channels. Produces triple waveform, allows you to adjust the frequency and pulse width independently on each channel through these 6 holes. You have pulse width and frequency, pulse width, frequency, pulse width, frequency. Allows you to manually tune and produce a resonance reaction.
How many amps does this draw at what voltage, and what does it put out?
This is designed where it operates on 12-volt automotive, but it has an 8-volt onboard regulator, and it keeps it stable.
So when you're going with resonance, it doesn't matter what volts you're putting through the cell, is that it?
Actually, it does matter. The lower the voltage, the more the efficiency, the less is lost through waste currents that create IR losses in the cell itself. Go to heating the electrolyte. But if you keep the voltage to the minimum that's required to give your potential across the cell, you're not really trying to do electrolysis, although that is a byproduct of the voltage there. What you're trying to do is you're trying to supply an abundance of electrons. The act of the electrolyte in my particular system does the job of carrying those electric fields into the solution through the cell. The water capacitor is not really that good of a capacitor. It has high leakage. But I found that the process, if you don't supply electrons to it, you end up with recombination of the gases that are produced, and you lose efficiency. So my approach was just something that I happened to luck upon. Okay,
and so this unit will work on what size chamber, how many cells, and that sort of thing?
This will work direct DC drive out to a booster type unit, a small booster type unit. You can take the output of this and apply it through a transformer, which you need to do anyways even with a booster unit in order to get resonance to use a transformer. But with the use of a transformer, you can also apply the same waveform to a higher voltage, what I call the bias voltage, which is your DC applied voltage to the cell. The higher voltage is affected with the waveform.
So what about the screw terminals? How would the hookup be made to those?
Well, in this particular one, you have your 3 inputs, auxiliary inputs. This has extra inputs so that you can apply external signal to it from another generator source.
Is that necessary?
No, this was allow so you could use any other type of waveforms you wanted besides what's built in on board. There's a disable control, which is the D, ground, gate supply, and B+. So you can operate this actually with a different voltage on the gate supply. So you can say run it on a 12-volt battery system and control a 24-volt electrolyzer system. You can go up to 100 volts with the MOSFET that's in this device. So if you want to go higher, you'd have to change the MOSFET and change a few parts values. So you can actually directly control higher voltages with it while it's operating off a lower. It has optocoupler that isolates the output from the input, And it's a high frequency optocoupler, good up to, well, we've tested up to 111 kilohertz.
Mm-hmm. So is this box capable of powering a small car?
Yes.
And how much would a box like this cost if it was mass produced on the open market, approximately, in your estimation?
A couple dollars.
Couple dollars. Yeah. So in other words, there's no reason why this technology should be out of the hands of the public. It's not cost prohibitive.
None.
And then what you need besides this is a chamber, which could cost maybe $100 to build, mass-produced or something.
The only reason why this system is not really good for end use is that it doesn't track the resonance action or reaction.
In other words, you need a computer to do that.
You need to be able to have feedback to
do that. You could build a small computer that's capable of keeping track of those functions.
Which is exactly what I've done here. This is the hex controller, which is this is an early generation. I actually have other generations of the PWM3, but this is the best that I've come up with so far, and this uses a microcontroller. It's an Atmel Atmega 48. It goes into this socket here. The processor is not installed, but this has a serial port coming in, broken out here on the side for connecting externally to a laptop or other type of computer for programming it. It also has a header for if you put a blank chip in here, so you can program the chip, a blank chip, while it's in here. So not only is it the controller, it's also a programming adapter. So essentially you can load this thing with a blank chip, put all the chips in it, send it out, and the end customer can program it. 3 of these inputs are safety inputs. So you can turn on and off each channel independently, or you can tie them all together and turn them on and off, using like a pressure switch. But the advantage of this, it also has 6 A to D inputs along this side that you can use to monitor feedback points on your cell, so you can vary your frequencies. So for every pair there's a safety.
So this awesome little device, together with what else, equals a water car?
You need a cell, of course, actually a series of cells to get the efficiency. I recommend at least 7 cells in series, and that will operate off of a 12-volt system, whereas a higher number of cells, you need obviously higher voltage to operate it. And of course the computer chip and the programming to make it operate. You'll need a feedback sensor on your throttle control to give a throttle sense.
To alter the
production on the fly, yeah.
But nothing else. In other words, you don't have to have an external transformer, or...
Oh, yes, you do.
Okay, so you do have
a transformer on all these systems. Computer power supplies contain a toroid that's this.
And you're saying something like that would actually work?
Something like this would
in a water car application
in a small 7-cell unit,
which would power a 4-cylinder, 6-cylinder, even 8-cylinder car.
Yeah, a smaller 8-cylinder.